Okay, geographers, here we go. First in our little series of revision videos on our work on rivers and coasts. I want to start this looking at the hydrological cycle and the drainage basin systems. Okay, pretty straightforward stuff. Now what we're going to look at when we do this is we're going to focus on open and closed systems, the differences between those, what they are, what the hydrological cycle is and what the main components of it are, and what is a drainage basin system and what are the inputs, outputs, stores and flows of that. I'm on a tight schedule here because it's half time in the Chelsea-Liverpool game, so I've only got 15 minutes to do this video. That's what I intend to stick to, hopefully. So, let's get started. Now from class, you should remember that there are two different types of systems, open and closed. Now, open systems are ones which allow stuff in and out. Okay, so you allow stuff to go in and out. Closed systems, right, is nothing comes in, nothing goes out, it just all stays the same. So if you think about these, represent these as two circles to start with. Okay, so here's our closed system, and then whatever's in it, you just merely go round and round and round and round. Okay, nothing ever changes, doesn't change, everything is equal within it. Okay, so the amount of stuff that was in that system in the first place is the amount of stuff that will be in that system forevermore. Okay, something incredibly drastic changes. An open system, on the other hand, we take the same sort of principle in a little circle. We've got stuff going round, round, round still, but the actual volume of that, the actual nature of that can change through something coming in and something going out. Now the bits that are coming in we call inputs. Stuff that goes out we call outputs. Okay, now really simple example is the one we're going to look at. We're going to look at water and like the water, what is it called? Water cycle or hydrological cycle as a closed system, and drainage basin, etc. as an open system. So within the water cycle, there is as much water as on planet Earth as there ever has been, and that doesn't really change. None is lost and no more is created. Okay, so in terms of the water cycle, the amount of water on planet Earth just goes round and round in a circle. It just changes its form. So you've got 97% of the water on Earth is in oceans. 2% is in its solid state in terms of ice, so it could be glaciers, snow, ice caps, whatever, icebergs. Okay, and then the remaining 1% is the stuff that we're interested in, and that's the fresh water that is easily accessible. So it's fresh water in rivers, etc. Rivers, lakes, ponds, whatever. Okay, now that is a certain amount of water. I can't remember how many billions of litres or trillions of litres it is, but it doesn't change, it just moves state. So sometimes it'll be clouds, sometimes it'll be as water vapour, sometimes it'll be as ice, sometimes it'll be as fresh water and so on. Now within a river basin, okay, we can add more stuff into it. These are smaller scale systems, okay, whereas the water cycle is global. Yeah, the river basin system would be a local scale. Okay, so think about the River Eden. The actual amount of water changes in the River Eden. The actual amount of water going through that system, that valley, changes through more inputs or less outputs. More often than not, in our case, more inputs because it rains a lot. Okay, so we can introduce, or nature, can introduce more water into the system by raining more. And what we can do is we can reduce maybe the outputs from that system. That might be through damming up a river. Okay, so if we put a dam in a river, it reduces the flow. Ooh, bam, dam reduces the flow. Okay. So those are the difference. One allows one stuff in and out. The other one is just closed. Nothing comes in or out. It just stays the same. It stays equal. It's in equilibrium. It's a good word for you. I'll Google it, see what it is. Okay. So first thing we're going to look at is we're going to look at an example of this closed system. We're going to look at hydrological cycle. Now, Key Stage 3, you might call it the water cycle. We are GCSE geographers now. We're going to call it the hydrological cycle. scribble that out so you don't remember. What I'd like you to do, first and foremost, is pause this video just for a second and make a very nice, neat copy of this diagram, okay? And then we'll go through and label it in a second. So if you pause the video now, it'll be ace. Okay, so hopefully now you've got your diagram drawn, and we're going to start to introduce the words that go into this. Okay? Now we're going to have a look at 6 different key terms. Think about it, I can't remember, but I think we'll just go for it and see how we get. One of them is condensation. Okay, I'll explain all these in a second. The next one is evaporation. These are in no order at all. Okay. Next one is precipitation. And then we've got transpiration. Surface runoff. And ground and through flow, sorry. Six. There we go. Okay. Now each of these terms relates to a specific point on the diagram, okay, a specific thing. Okay. Now suppose what this diagram is actually missing is a sun. The top goes without that. None of this works. Okay. So what the sun does is it introduces heat. Now down at the bottom here, in this area, we have the sea. Okay, so this is the world's oceans, if you like. And what the sun does to this world's oceans, it heats it up. And as water heats, it turns into water vapor and evaporates. So there we go. Evaporate or evaporation, if you want. Evaporation. Okay. Now, when that water evaporates, as it goes up through the atmosphere, it starts to cool. And this is the same sort of thing as if you put a cold plate over the top of the kettle, so steam rises out of the kettle. If the plate, that steam, that sort of watery gas, if you like, turns back into water droplets. This is called condensation. So in this case, the water vapor from the evaporation is condensating and turning into clouds. Okay? We're going to track over to this side for a second. Okay? Now what we've got here is trees. Trees like water. Without water, trees don't survive, and they store water throughout them, so in their leaves, in the bark, whatever. So this still will let water back out into the atmosphere. As those trees heat up, the water within them leaves the trees. Okay? This is a slightly different process to evaporation. It's called transpiration. Okay? So transpiration is the movement of water out of trees into the atmosphere. Okay? So like evaporation is movement of water off the land, if you like, into the atmosphere. This is out of trees and vegetation into the atmosphere. Okay, and then when that water goes into the atmosphere, the same thing happens as it would do in evaporation. It cools and it condenses to form water droplets and clouds. Okay? Now, like all good things, what goes up must come down, and here we have those water droplets now falling back to Earth. This could be rain, sleet, snow, hail, whatever, and this is called transpiration, or that precipitation. Okay, so precipitation is anything that falls from the sky, not cats and dogs, but anything watery. Okay. Next thing we've got to think about. So we've got out of our key terms now. We've used that one. We've looked to know what it is. We've used that one, know what it is. Used that one, know what it is. Use that one. We'll look at surface runoff and through flow. So surface runoff is anything where the water flows over the land. So that could be a river. Thinking about the football now, can you hear it? A river, a stream, or whatever. Okay, so that is depicted here. So water flowing over the ground. over the surface, running off over the surface. Okay, and that's going into the sea. Then it evaporates, condenses, falls as precipitation, moves back down again, and so on. It's the cycle. Okay, and then we've got the through flow, which is water that runs through the ground. So as water sort of lands, some of it soaks in, it flows under the ground via gravity back into the sea. As it gets to the sea, it evaporates, and so on. So some of that water might get sucked up by the trees again, and as it gets sucked up by the trees again, it goes through transpiration, condensation, precipitation, and so on. Okay, so the last one we've got to add here is through flow. Okay, so that's basically the water cycle. Nothing's ever leaving this cycle. This is all staying in there. There is no output, no input. It's just going round and round and round and round and round. Does that make sense? Okay, so water just flows all around in various different forms. So it goes from being solid, maybe, in terms of the ice, which might melt into surface runoff from within the sea. As a liquid, that liquid then gets heated by the sun. As it gets heated, it evaporates, condenses, and falls. Say as snow. Snow then turns to ice, ice melts, and so on. Does that make sense? It does. Right, so I've done that. Make a note of these key terms. Okay, and if you sort of missed any of the definitions or whatever, replay the video. If you're still struggling to get your head around it, have a look at bite size. Okay, and geography pages, and that should help you. Definition. Okay, or see me too. So this is a closed system. We're going to move on to look at the open system now. So this is our drainage basin system, which is an open version of an open system. Okay, sun again, dead happy lad. What I'd like you to do is pause the video again and make your own version of this diagram. I know it looks complicated, but it's really important that you know and be able to label one of these diagrams, so that's quite a common exam question. So if you pause the video now and make a quick copy of the diagram, and then we'll get started again. So diagram drawn, everyone's happy. In this one here, we've got 4 different things to consider. Okay, and you need to be able to give examples of each of these as well. Okay, so you need to be able to give an example of an input, and that is indicated by the light blue at the top here. Okay, text message. You need to be able to give an example of a flow. Okay, which are in the green. It's here. And you need to be able to give an example of a store, which is the dark blue bits here. And you need to be able to give an example of an output, which is the red boxes. Okay, so input in, output out, out. Flow is move, and store is keep. Okay, so something in, something moving, something staying where it is or being kept somewhere, and something out. Okay, and we're going to start with the out. That's the easiest bit. Well, if you were listening last time, I did the diagram is. So, water being something from a tree into the atmosphere, lost to the atmosphere from trees or vegetation. So we're doing with T, transpiration. Okay, the movement of water from vegetation into the atmosphere. Water being lost from the land into the atmosphere is an example of evaporation. Okay, and if you think about it, now this the wind blows. We've got a cloud here, and it blows. This water vapour could end up absolutely anywhere. It could go elsewhere, somewhere else in the world, somewhere else in the country. Okay? And when that condenses, falls with rain, that could fall somewhere else. This is a very local system. Okay, so it's not specific to a particular place. Okay. Here we've got something leads to the sea. What could that be? River? Stream? Something like that. Something that flows and removes the water from that particular area. Takes it out to the sea. So there we go. 3 outputs. Okay. Transpiration, evaporation, and actual river itself. Another text message. Okay. Now we're going to look for the inputs. Now there is only one of these, and that is water that falls from the atmosphere and in, if you like, and that, remember, is precipitation. Get it? It's almost legible. Okay? And precipitation falls, that's water falling from the sky in the form of snow, hail, sleet, rain, whatever. Okay? So those are the two easiest bits done. Okay? The in, precipitation, and the outs, transpiration, evaporation, and natural reflex out towards the sea. The next bit is how that water actually moves around. Now, if you think about it, we've done a couple of these already. And we did the water that runs over the surface, part of the other one is surface runoff. And we did the water flowing through the soil or through the ground. This is next through flow. And then there's another one here, which is right down in the depths of the ground in the water table, and this is called groundwater flow. Okay? Now, through flows through the soil. Groundwater flows through the rock or the water table at the bottom. Okay? So that's really, another text message, that's really deep there. Okay? So through the soil, groundwater through the ground, through the rock. Now, if we go back up here, water then can go down through into the soil. Okay? This is known as infiltration. Okay? Now, infiltration is what it says in tin. It's water infiltrating through the soil and into the soil. Okay? So it infiltrates down through the ground surface and into the soil. Now, below that, we get something called percolation. Okay? And percolation is where water keeps on going down, it goes through like cracks in the rock. That only happens if you have something that's called porous rock, okay? Or permeable rock. And permeable rock means that it's got holes in it, so water can actually go through it. So it's not like it's got little gaps within the rock for water to go through. If you've got impermeable rock, then the water sort of just sits on the surface around here because it can't penetrate it. Okay? So there we go. We've got our 5 flows done. Now, last but not least, and this is the last little bit for this this tutorial, we need to have a look at what the stores are. This is where water is kept. Now, if we start at the top, water is actually kept in trees. Okay, it's kept in the leaves, on the leaves, in the bark, whatever. Now, as that water falls from the sky, these trees intercept it, and when it intercepts it, that's where it's kept. So we call this one where it's stored by the trees as interception. Okay, that's water being stored on the leaves of the tree or leaves of vegetation or whatever. Okay, that water that's stored on those leaves can then be transpired into the atmosphere. Next one down is where we get water stored on the surface. Okay, we just call this quite simply surface storage. Okay, where water is stored on the surface, so that's things like ponds, lakes, puddles, whatever. Okay. Now going down again, as the water is stored in the actual soil, okay, it's stored as soil moisture. So we call this soil moisture, the text, storage. Okay, soil moisture storage. So when you dig a hole and the soil's wet, rather than all dry, bone dry or whatever, it's the water being stored as soil moisture. Okay, and then right down at the bottom, the last thing we've got to add here, okay, is what we call groundwater. I've lost my pen. Groundwater. Okay, and groundwater is the stuff that's stored beneath the soil in the rocks in the ground. Okay, and it's where you find the water table. The water table is sort of like the highest point of the groundwater. So this line here would be represented as the water table. Okay. Now, as a little activity, what I'd like you to do next is go through, okay, and shade in the inputs in light blue, the stores in dark blue, the flows in green, the outputs in red. Okay, hope this first tutorial has been useful. Here we go. Go.